Today in this video, we're going to see about feature scaling method in data science. So let's get into it. So first of all, what is feature scaling? Feature scaling is a technique to standardize the independent features present in the data in a fixed range. So it is for normalizing the data. It is performed during the data pre-processing to handle highly varying magnitudes or values and limits units. So, and if feature scaling is not done, then a machine learning algorithm tends to weigh greater values higher and consider smaller values as a lower values regardless of the unit of the values. So some of the examples, feature scaling is a method used to normalize the range of independent variables or features of data. In data preprocessing, it is known as the data normalization and is generally performed during data preprocessing step. So for example, if you have multiple independent variables like age, salary, height within their range as 18 to 100 years, 25,000 to 75,000 euros, 1 to 2 meters respectively, feature scaling would help them all to be in the same range. Okay, so for example, centered around 0 or in a range of 0 to 1, 0 comma 1, depending on the scaling techniques. So feature scaling purposes are basically normalization, algorithm performance improvement, and preventing numerical instability. So methods of feature scaling. So first one is standardization. It's also known as z-score normalization. It calculates the z-score of each value and replaces the value with the calculated z-score. The z-score can be calculated by the following formula, which is x dash is equal to x minus x bar by sigma, where sigma is the variance and x bar is the mean. The features are then rescaled with x bar is equal to 0 and sigma is equal to 1. So the library we're going to use is standard scalar. Here's the coding part. So let us import pandas as PD from scipy, import stats, import numpy as np, and then we are going to read the CSV file BMI using the pd.readcsv function, and then we're going to see how the data is being stored, how the dataset is being there by using df.header for checking how many features are there like gender, height, weight, and index. So that now we are going to drop the null values from the dataset by using df.drop_na, and then we are going to find the max values using the np.max of and np.absolute of the features height and weight from the dataset, and storing it in the max values. So now when we access that, we get the height is equal to 199 and weight is equal to 160. So now for importing standard scalar, we need to take it from the SQL and preprocessing library to use the standard scalar. So from SQL and preprocessing, import standard scalar, and we are going to store that standard scalar into a variable named SC, and then now we are going to fit transform the features height and weight using the standard scalar variable, that is SC, to the same features, that is height and weight, in the same data set. And now we are going to check how the data is being changed. Now we could see that the height and weight have been changed from the starting data set to the standard data set. Second one is min-max scaling. It is also referred as a normalization, and feature scale between 0 to 1 only. There will be no negative values like how we saw in the previous scaling method. So here the mean value remains same as standardization, and that is 0. The formula is given as x dash is equal to x minus min of x divided by max of x minus min of x. So we're going to use the library min max scalar. So again from scalar and pre-processing, import min max scalar. Scalar is equal to min max scalar, so that we are going to store that min max scalar function into the scalar variable. So now we are going to fit transform the height and weight features using the scalar which contains min max scalar, and to the same features height and weight in the same dataset df. Now we are going to check the data. There will be no negative values, and the height and weight values are being only between 0 to 1. And third one is normalization. This method is more or less the same as the previous method, but here instead of minimum value, we subtract each entry by the mean value of the whole data and then divide the results by the difference between the minimum and maximum value. So the formula for this is x scaled is equal to xi minus x mean divided by x max minus x min. So here is the coding part. For scalar under pre-processing, import normalizer and then scalar is equal to normalizer. So we are going to store that normalizer function into the variable called scalar. And then now we are going to fit transform the features height and weight from data set using the scalar variable which has the normalizer function to the same features height and weight in the same data set. Now we could see that height and weight have been changed from the previous scaling methods. This is how the normalizer works, and then maximum absolute scaling. So this scales the data to its maximum value. That is, it divides every observation by the maximum value of the variable. So the result of preceding transformation is a distribution in which the values vary approximately within the range of -1 to 1. So it can have negative values as well as the positive values. So we could use the library named MaxAbs Scaler, and the formula for this is x scaled is equal to x by max x. So the coding part is this, so that we're going to read this file again as df3 and then from SQL under pre-processing import MaxAbs Scaler, and we're going to store that function MaxAbs Scaler into a variable called scalar, and then now we are going to fit transform this features height and weight using the variable scalar which has the function max app scalar to the same features height and weight with the same data set. So you could see that height and weight have been again changed from the previous scaling methods. This is how this max app scalar works. And then the robust scalar. Robust scalar transforms the feature vector by subtracting the median and then dividing by the interquartile range, nothing but 75% value minus 25% value. In this method of scaling, we use two statistical measures of data, which is median and interquartile range IQR. So the formula is x scale is equal to xi minus x median by IQR. After calculating these two values, we are supposed to subtract the median from each entry and then divide by the result by the interquartile range. Here's the coding part. We're going to again read the CSV file in a different data frame, and then we are going to implement from sklearn.preprocessing import robust scalar, whereas we're going to store that robust scalar function into a variable called a scalar again, and then now we are going to fit transform the features height and weight from the data set using the scalar variable which has the function robust scalar to the same features height and weight in the same data set. And we're going to check the data how has it been changed. We could see the height and weight have been again changed from the previous scaling methods. And now feature scaling techniques. So these are of two types, which is supervised feature selection and unsupervised feature selection. And from the supervised feature selection, we have three main categories, which is filters method, embedded method, and then wrappers method. In filters method, it involves with missing values, information gain, chi-square test, and Fisher score. And then embedded method, it involves in regularization L1, L2, and random forest importance. And then finally wrappers method, it involves with forward feature selection, backward feature selection, exhaustive feature selection, and recursive feature elimination. So thank you for watching this video. I hope you like this.